Picture this, January in Paris. But not the Paris of romance, bustling cafes, or lovers strolling along the Seine. Instead, imagine a city gripped by an unrelenting icy siege. The streets are eerily quiet, muffled by thick blankets of snow. Cars are buried, and the familiar hum of city life is replaced by the crunch of boots on frozen pavement and the distant howl of a winter wind that never seems to stop. The Eiffel Tower, usually a beacon of light and life, now stands draped in jagged icicles. Its iron frame glistens with frost and its lights flicker dimly against a sky heavy with snow. The city's most iconic landmark is transformed into a monument to winter's power, a silent witness to the deep freeze that has settled over Europe. The River Seine, once flowing and alive with boats and reflections, is now frozen solid. People bundled in layers of clothing skate cautiously along its icy surface. The riverbanks are lined with snowdrifts, and the air is so cold that every breath feels sharp. The city's heart has stopped beating, replaced by the slow, careful movements of those who dare to venture outside. This isn't a scene from a disaster movie or a work of science fiction. It's a scientifically plausible future, one that could unfold if the Gulf Stream, the powerful ocean current that warms Europe, were to collapse. Imagine Venice's famous canals locked in thick ice, gondolas trapped and useless. Ireland's rolling green hills, usually lush and vibrant, are buried under relentless snow. Even Spain's sun-drenched vineyards stand barren, their vines withered by a cold that refuses to let go. The entire continent is transformed, its landscapes unrecognizable beneath a shroud of winter. Major ports like London and Hamburg, vital arteries for trade and travel, are choked with sea ice. Ships sit stranded, unable to move for months at a time, commerce grinds to a halt, and the economic impact ripples across the globe. Europe, thrust into a new ice age, faces a daily struggle for survival. People battle blizzards just to reach food or fuel. Cities adapt to a new reality, where warmth is a luxury and every day is a test of endurance. Energy grids strain under the constant demand for heat. Food becomes scarce as farmland lies frozen and supply chains falter. The familiar rhythm of the seasons is lost, replaced by a single, endless winter that reshapes every aspect of life. This isn't just about colder weather or a few harsh winters, it's a fundamental shift in the very habitability of the continent. A transformation that would force millions to adapt, migrate, or face the consequences of a world turned cold. How could such a dramatic change happen? The answer lies not in the sky above, but deep within the Atlantic Ocean, where powerful currents shape the climate of entire continents. The Gulf Stream, a massive river of warm water flowing from the tropics, has shaped Europe's mild climate for thousands of years. It acts like a giant conveyor belt, delivering heat and moderating temperatures across the region. But now, this vital system is showing signs of stress. Scientists are racing to understand the changes, monitoring ocean temperatures, salinity, and currents with growing concern. The story of Europe's future is being written in the language of water, salt, and temperature, an intricate balance that, if disrupted, could tip the continent into a new and dangerous era. To avoid this frozen fate, we must look beneath the waves and understand the powerful forces at play. Only by studying the ocean's secrets can we hope to protect the world we know. The stakes are nothing less than the future of European civilization, a future that hangs in the balance, waiting for us to act. To truly grasp why Europe's climate is so unique and temperate, especially compared to other regions at similar latitudes, we need to look beyond the land and turn our attention to the vast, restless ocean, the Gulf Stream. This mighty ocean current is one of the most important natural forces shaping the weather and environment of Europe. The Gulf Stream begins its journey in the warm waters of the Gulf of Mexico, gathering heat from the tropics. It then sweeps up the eastern coast of the United States, acting like a massive conveyor belt, before veering eastward across the Atlantic Ocean toward Europe. Think of it as a planetary hot water pipeline, transporting vast amounts of tropical warmth northward. This is what makes Europe's climate much milder than you'd expect for its northern position on the globe. As the Gulf Stream crosses the Atlantic, it transforms into the North Atlantic Current, releasing its stored heat into the atmosphere. The westerly winds then sweep this warmth over the European continent, creating a climate that is surprisingly gentle. That's why cities like London experience relatively mild winters, and why Norway's coastal ports remain ice-free, even when other places at similar latitudes are locked in ice and snow. The Gulf Stream is a crucial part of a much larger system called the Atlantic Meridional Overturning Circulation, or AMOC. This is like a giant conveyor belt in the ocean, moving warm, salty water northward, where it cools, becomes denser, sinks, and then flows back south deep beneath the surface. This sinking process is the engine that keeps the entire system running, driving the continuous movement of water and heat around the planet. Without this powerful circulation, the steady flow of warmth to Europe would slow dramatically, or even stop altogether, leading to much colder conditions. For thousands of years, this oceanic system has quietly acted as Europe's silent climate guardian, shaping the seasons and supporting life across the continent. But this stability is not something we can take for granted. The balance of this system is delicate and can be disrupted. Today, human activities like burning fossil fuels, releasing greenhouse gases, and causing Arctic ice to melt are interfering with the mechanisms that keep this ocean engine running smoothly. The fate of the Gulf Stream is closely tied to our own. If it weakens or collapses, the consequences for Europe and the world could be profound. If this current falters, Europe could face much harsher winters, shorter growing seasons, and dramatic changes to its way of life. That's why understanding the Gulf Stream and its role in our climate is not just a scientific pursuit, it's crucial for planning our future and protecting the world we know. The ocean conveyor, also known as the Atlantic Meridional Overturning Circulation, runs on a simple but powerful principle: density. Cold, salty water in the North Atlantic becomes denser than the surrounding water, causing it to sink deep into the ocean. This sinking action acts like a giant pump, pulling warm surface water northward from the tropics, which in turn helps regulate the climate of Europe and much of the northern hemisphere. But climate change is rapidly altering this balance. Greenland's massive ice sheet is melting at an unprecedented rate, pouring vast amounts of fresh water into the North Atlantic. This influx of fresh water is not just a trickle, it's a flood, and it's changing the very chemistry of the ocean. As this fresh water mixes with the salty ocean, it dilutes the surface, making it less dense. The lighter, fresher water resists sinking, disrupting the conveyor's crucial downward flow. This seemingly small change in density can have enormous consequences for the entire system. Without the sinking of dense water, the conveyor belt weakens, slowing the entire circulation. The once steady flow that has persisted for thousands of years is now faltering. Scientists have already measured a 15% slowdown in the Atlantic current system since the mid-20th century. This is not just a theoretical concern. Real-world data shows the system is losing strength. The system is showing signs of arrhythmia, a once steady beat now faltering. Like a heart struggling to pump blood, the ocean's circulation is becoming unstable and the warning signs are growing more urgent. As the AMOC slows, less warm water reaches Europe, threatening to plunge parts of the continent into colder, harsher winters. Meanwhile, the Arctic continues to melt, adding even more fresh water and creating a dangerous feedback loop that accelerates the problem. The slowdown doesn't just affect the ocean. It disrupts both oceanic and atmospheric patterns, altering weather systems, shifting storm tracks, and increasing the risk of extreme weather events across Europe and beyond. We're tampering with a planetary system we barely understand. Despite decades of research, the full complexity of the ocean conveyor and its tipping points remain a mystery, making our current actions all the more risky. The consequences of pushing this system past its tipping point could be catastrophic and irreversible. Europe's climate, agriculture, and way of life could be transformed in ways we can hardly imagine. The Gulf Stream's collapse isn't just a distant theory. It's a real, growing risk that scientists are warning about with increasing urgency. The stakes are higher than ever. The balance of temperature and salinity in the ocean is incredibly delicate. Even small changes can tip the scales with far-reaching consequences for global climate and weather. If we keep adding fresh water at the current rate, the system could grind to a halt. The conveyor belt that has stabilized our climate for millennia could simply stop, with little warning. The fate of Europe's climate truly hangs in the balance. The choices we make now will determine whether Europe faces a future of stability or one of chaos and disruption. The time to act is now, before the tipping point is reached. Our window to prevent a shutdown is closing, but with decisive action, we can still protect the climate system that sustains us all. If the Gulf Stream stops, Europe's winters could drop by 5 to 10 degrees Celsius, turning Paris and Berlin into Siberian outposts. Agriculture would collapse, wheat, olives, and grapes would fail, and food shortages would follow. Extreme weather would become the norm. Brutal winters, intense storms, and parched summers. Energy demands would skyrocket, straining power grids and economies. Transportation would grind to a halt, and infrastructure would buckle under the cold. Mass migrations could reshape the continent as people flee the frozen north. The Europe we know would vanish, replaced by a land of hardship and uncertainty. This is not just cooling, it's total destabilization. The Gulf Stream's collapse would ripple worldwide. Sea levels along the US East Coast could rise by a meter, flooding cities. Tropical heat would build up, fueling stronger hurricanes and shifting rainfall patterns. Catastrophic droughts could hit the Amazon and Africa, while floods strike elsewhere. Marine life would suffer as nutrient flows collapse, devastating fisheries. The southern hemisphere could warm, accelerating Antarctic melt and global sea level rise. Weather and ocean currents would shift unpredictably, threatening global stability. The AMAC's collapse would unravel the planet's climate tapestry. This isn't science fiction, it's a looming reality. The AMAC is at its weakest in over 1,000 years, and past records show it can collapse abruptly. Recent studies warn we may be near a tipping point, with collapse possible as soon as 2025. The system may appear stable until it suddenly flips, like a canoe tipping over. Greenland's melting ice is pushing us closer to disaster. No one can predict the exact year, but the risk grows with every ton of carbon we emit. The scientific consensus: we're playing a dangerous game with a critical climate system. Ignoring the warnings would be reckless. The time to act is before we reach the point of no return. Our window for prevention is closing fast. The Gulf Stream's fate is in our hands. The solution: stop fueling climate change by ending fossil fuel use. We need a global energy revolution, massive investment in renewables, smarter grids, and policies that make clean energy the default. Protecting forests and restoring blue carbon habitats like mangroves and seagrass is vital. These natural systems pull carbon from the air and stabilize the climate. We must think long-term and act globally. Climate knows no borders. International cooperation and shared technology are essential. The challenge is immense, but humanity has overcome great odds before. Our ingenuity and collaboration can safeguard the ocean currents. The story of our future is still being written. Global change starts with individual and community action. Reduce energy use at home, insulate, use efficient appliances, and turn off lights. Choose sustainable transportation. Walk, bike, use public transit, or drive electric. Support policies for clean energy and better transit. Shift toward a plant-rich diet to lower your carbon footprint. Even small changes like meatless Mondays or local produce add up. Use your voice, vote for climate leaders, join advocacy groups, and talk about the issue. Every action signals demand for change. Together we create the political will for systemic solutions. Protecting the Gulf Stream starts with us. The Gulf Stream's story is a warning, but also a call to action. We have the knowledge and tools to change course. The solutions are in renewable energy, restored ecosystems, and our collective will. Our greatest strength is our ability to foresee danger and choose a better path. Let's ensure future generations know of a frozen Europe only from history, not experience. We are the custodians of this blue world. The future is unwritten, and we hold the pen. Let's write a story of hope, courage, and action. The balance of our planet depends on what we do next. The time to act is now, before the currents change forever.